Now let's see the first lesson, box animation. In this box animation, we'll see how to move the box from one location to another using the buttons so that it depicts what's happening in the real environment. Alright, so the first step is let's monitor its HMI screen elements. If you see here, the animation is done by the box and this rulers. Alright, so let's see the HMI screen, and here it is. Now if you notice here, we have this box, and actually I have grouped this element. So what I will do is I will right click this one and I will show you edit group. Now in this group element I have this box. So if I double click on that, you will notice in the animation there is a horizontal movement added. Alright, so let me show you this horizontal movement, how to add this in an example. So what I have actually done is I have took a rectangle, and this one you can see here, properties, you can change its color. Alright, now I have added a animation element to this one. So double click this one and go to animation and click movement. In movement you have add new animation. So take horizontal movement in this example. Alright, click on OK, and now you will notice the range of your animation, how you want to animate that, to what particular distance you want to animate this one. So you can choose as per your requirement. For let's say example, I'll take this one. Alright, so I have my animation element from this location to this location. Now I have to give it some tag which will define its movement. Alright, so in our case this animation has been given tag 14. Okay, now this tag 14, let's see what is this tag. I'll go to HMI tags. This tag 14 represents capacitive int, which is integer. Alright, so let's move to our PLC logic now. In the box logic, if you notice, we have capacitive int here. So what's actually happening? We are reading the value of capacitor analog, which is the sensor in our element. So in our factory IO, this is the sensor. This capacitive sensor is giving us 0 to 10 volt. We are reading its value. Now if I go to my drivers, you will notice this capacitive sensor is connected to ID30. Alright, this is my register which is reading the value from the sensor. So in our program, ID30 is here. So this is having some value. We are converting this value into real value, which is 0.05 compared to what's written here. Alright, so in real value we are getting the range of 0 to 10. So if you notice here again, I would like to show you. Just notice this value. This is 10.0 because this is giving us 10.0 here. And if it is 2.7 here, we are getting approximately 2.7 here. So this value is actually representing this value because we have to convert the value from the word to real in our example. Alright, generally what you get here is the analog range, of which depends upon the resolution of your analog input. But because we are using a simulation to explain that, so we have some range of values here. But in your case, the range would be different. So you may have to scale it differently. Alright. So once you do the scaling, you have to get the scale value of 0 to 10 here, or you can take 0 to 100. It depends upon you. Now this 0 to 10 is in real format. We have to convert that into integer format because we cannot use real register for animation in the HMI. So we have to convert the 0 to 10.0 to 0 to 10 in integer. So if you see here, it's 3. And now if I further keep moving it, it will go up to 10. So the value I'm getting is 0 to 10 in my register capacitive int. Alright, so this capacitive int is 0 to 10. Now let's go back to our HMI screen. If you notice this box, in this animation, you will notice the range is given 0 to 10. So this will actually move from one location to another location by changing the value from 0 to 10. So at 10, this box will be at this position. You can see this is in faded color, right? At 0, this box will be at initial position. So 0 to 10 is actually moving the box from here to here, because the range is given 0 to 10. If it is at 5, this will be at the middle position. This is how the animation works in this HMI. So this was the animation part of box. All right. Now next was the animation part of this roller. Now this roller I have designed in Microsoft Paint. So if you see here, the roller, you can design that in your paint. You have to make a circle, make some lines and fill it up. So similarly, I have designed 4 different diagrams which I can use to depict the rotation of my rollers. All right, so let's go to the graphic element, and here you will notice roller, and this roller is given 4 values. Like one range is 0 to 249. In this range of value, this graphic will be displayed. In the second range, this graphic will be displayed, and so on. So we have 4 graphics which are being shown depends on the value of the register, and this register, we will see what is this register in our PLC. All right, so let's go back to PLC logic now. Now in PLC logic, we know that the rotation of this roller based on the direction of the motor. If motor is in clockwise direction, it should shows clockwise rotation. If motor is moving in this direction, anti-clockwise, it should show another direction. All right, you can see here. So to understand that, let's see the logic. So study this logic, what is happening here. We have this bit to actuate the output, and this bit move box left. This bit is actually this one. So this is my button, and you can see its event. This is tag 7 of my HMI, which is actually move box left. And similarly, this is another tag, tag 5, which is move box right here. All right, so these 2 buttons are actually actuating the outputs. So move box left is actuating this output Q0.1, and if you see here in the factory IO, Q0.1 is roller conveyor for one direction, Q0.2 is roller conveyor for other direction. So understanding this factory IO is another thing. If you don't have factory IO, if you have a real output, so you can use that. All right. This motor Q0.1 is actuating a timer. Now we are using a timer for the animation here. Okay, because our motor is a digital output, it's only on and off, but we need a variable which will show the animation. Okay, so we take this variable by using a timer. So timer is actuated by a motor bit. The range of timer is 1 second. Okay, we have converted this range of 0 to 1 second of this timer, which is 0 to 1000 millisecond, into we have converted that range and into integer, and that is stored in MW65. Okay, so this MW65 is the integer which is used for animation. Okay, so what happens when we move the motor initially clockwise? In clockwise, we have another timer. We are using 2 timers. Okay, one for clockwise, one for anti-clockwise. So in the clockwise, we have a timer running from 0 to 1 second or 0 to 1000 milliseconds, which is converted into integer and stored in MW60. Okay, and when the value of the timer reaches 1 second or 1000 millisecond, the timer reset. It means when the clockwise motor is on, like here, this is keep running, and you can see the timer, it's keep resetting. So the value in MW60 is coming from 0, 1, 2, 3, 4 up to 1000, and it keeps resetting. Okay, and now you can imagine this rotation of this roller is getting the value from MW60. Okay, because when the value is from 0 to 250, it has one frame. When the value is from 250 to 500, it has second frame, and so on. So let's see the HMI, and let's notice the animation. Okay, so here, go to general, it's given tag 23, and that's also tag 23. So let's see the tag 23 here. This is tag 23 in the PLC. Which you can see tag 23 is here, which is MW60. So this value is being monitored, and that is used to animate the rollers. Alright, similarly here we are using M60, which is tag 23. Now in the anti-clockwise logic, you may notice the direction is opposite. So how to do that? The simple logic is you subtract the value of this MW60 from 1000. Okay, so when you subtract the value of this MW60 from 1000, you can show anti-clockwise rotation, because the bits will be shown in the opposite, how should I say, it will be in descending order. So you will notice here, just notice the value in MW60. This is shown in the reverse, decrementing. It is decrementing. But if I press this one, it is incrementing. So simply incrementation and decrement you can show using subtraction logic. Alright, this is a simple mathematics, and you can implement that using this. So this is how we can animate our box of the real environment, and you can simulate it using the sensors and also using the timer logic for the rollers. I hope this lesson makes sense. If you have any doubt, you can post me a comment. And also I'm going to upload this whole logic of HMI and PLC in our NFI secured page, and you can download from there. Alright, thank you for watching. I'll see you in the next video.